OLTP is nothing but current data. No history is maintained. OLAP is history data, and which is it is completely gives analytical info, and whereas history it will give tactical info. So if you wanted to create OLAP systems which are nothing but data warehouses, DWH. So you need to maintain the history through some of the ETL tools. You can take any ETL tool. It can be MSBA, SSIS, Ab initio, Talent. There are many tools in the market. It's all about your choice, which one you're going to choose. So, what apart from those, we got latest cloud tools as well, which in terms of ADF, Databricks, so all those. So many tools are there in the market. It's all about your convenience, which tool you're going to choose. So this is all the things we discussed yesterday, and how we create data warehouse also we discussed yesterday. Strategic information, and differences between operational and analytical means left hand side it is OLTP, right hand side it is analytical. And we had seen the definition. Data warehouse, it's subject oriented, right? For any client is there, we will create a different subject area of data warehouse. So and they integrate different sources. That's why it is called as integrated and time variant, non-volatile. So non-volatile, it will be stored permanently. Now, unlike OLTP systems, OLAP systems are mostly created. So one point I would like to mention here is there are plenty of tools, OLAP tools. So OLAP tools are divided into two sections. One is ETL, second one is reporting. So ETL, as I mentioned, data stage, Ab initio, and then MSBI, any Informatica, many other tools. Reporting side, what we do have is Power BI, which is trending in market, and Tableau, and there are many. IBM Cognos. It was my main skill set actually. I started my career with this tool only, and then I moved on to Tableau, Power BI, and so on. So and then SSRS. There are many tools actually, not only these. There are many tools. So, but intention here is ETL tools for creating data warehouse, building the data warehouse. So reporting tools for consuming and creating user understandable informative reports. Clear, right? Informative reports. Okay. User understandable informative reports will be created based on reporting tools. So these are the people who consume. These are the people who create the data warehouse itself. Clear, right? So what type of data it will be stored in data warehouse? Historical data, and then subject oriented, integrated, historical data, read only data. Data warehouse data, you will not be able to delete that much easily unless until there is a specific reason. Once data warehouse data is stored, right, people will not change the data that much easily. For sure, actually, at least 99% people won't change the data warehouse data. That's why it is mentioned read only. So some of the features and advantages, that's what we discussed, and which are all the areas where we use data warehouse. So this is important concept. Data marts, subset of data warehouse is nothing but data marts. I told you, whenever you want to create a data warehouse, how people best practice what they do is they will collect the OLTP sources, right, or transactional sources we call it as. These are the sources what they transaction sources. I don't know why my keypad is not going good. Yeah. So OLTP sources or transaction sources or some Excel files. They consolidate all the Excels, right, and then they integrate into one common area. We can call it like a raw layer or staging layer, and then they do transformations on top of it, and they create data marts, separate data marts for each and every subject area, specific domain. specific product. If you take any client, so they create the data marts, and then they create the data warehouse. So the main agenda here is, if there are any corrections, let us do the corrections quickly inside the data marts, and then consolidated data can be loaded into data warehouse. So fault redundance, so the faulty records or any other any such corrections can be made in terms of data marts, and whoever the people wanted to use on data marts, they can be able to take the data marts rather than giving full access to data warehouse. So that is also other purpose. Mostly people follow like this. There are chances of deviating this also. First they create data warehouse, on top of it they create data marts also. Either the way is fine. Both are possible, but mostly the first one approach we are going to choose. Okay, so I will tell you in detail. There is another slide is there, we'll discuss there. So these are the features of data marts: low cost, controlled locally rather than centrally. So we can quickly update data marts compared to data warehouse. There are disadvantages also because of data marts, because if you want to see holistic data, big data, you cannot see in data marts. Obviously you need to again rely on data warehouse. So now we are in architecture phase. Yesterday, as of where here we got stuck actually. So as I shown here, first sources collection. Once you are familiar with the sources, right, then we will be loading them into a staging area. In our case, right, in Azure Data Engineering side, this staging area is nothing but a raw layer. You won't do any changes. Just replica of data we copy into our ecosystem, from other ecosystem to my ecosystem. That's it. So we maintain the metadata of the tables what we are bringing in. That's what the metadata, and enterprise data warehouse will be created after the transformations, which will be given for end users like Power BI, reporting tools, Tableau, IBM Cognos, whatever it is. That's how it is. And next one is ODS. See, now if you understand correctly, you are seeing like a data warehouse and data mart. Data warehouse will take years. To be frank, in my system, we had built an brand new data warehouse from the scratch. It took almost 2.5 years to 3 years for us, starting from upgradation from the oldest system, on-premise system, wherever the different servers of data, different files of data, whatever was stored, right? We brought into our system. It took almost 2 years of time. On top of it, doing the best practices and the additional tables whatever required, and the compatibility with the Azure Data Engineering. All those aspects we have introduced right into the data warehouse. It took 4.5 years also. Even it's still continuing. We are implementing more and more enhancements. That's how. So in case of data marts, it will be quicker compared to data warehouse. Definitely, probably some 3 months, 4 months, something like that will take. So build up. So, but there is in between, we do have something else called as operational data store. It is in middle, in between data marts and data warehouse. So it is quicker than data marts, and it will be like it is just it will not store historical data. So it is hybrid kind of data warehouse actually. See definition here. See integrated, same like data warehouse. Subject oriented, same like data warehouse. So but it is volatile, where updates can be done. This is the one change between data warehouse and data store. Data warehouse and data store. ODS we call it as. It is also same kind of system only, but some cases, very rare cases, all the people will not choose this. Just very few people who wants to do the changes frequently. That means data cannot. They don't want to maintain non-volatile, which is permanent. They don't want to maintain where the frequent changes are happening, right? Then they choose ODS. But in my experience, so far I haven't touched it actually. So it is current valued also. Some little history also maintained actually. So it is not so much of aggregated data, detailed data only, right? So we'll see the more differences. So difference you see, updated schedule daily or less time frequency. As I told, data warehouse can be daily, weekly, monthly also, but this guy ODS will take daily or less also. So details of data mostly between 30 to 90 days only, maximum of that much of history only we maintain, not full history like 30 years, 1 year, 2 years, not like that. Limited history we maintain in the ODS. So this is also for operational needs like OLTP. It's a combination of both actually. Let me take you this. It will make you more clarity. Data warehouse properties, right? Data warehouse properties, integrated and subject oriented. We consolidate, we integrate from multiple sources and create different subject oriented data warehouses. That's what point says. So it is possible in both ODS and data warehouse. And so update by transactions, yeah, it will only be done in ODS. Data warehouse we do, but less frequently. So it is once data is stored, we maintain other record, not going to correct the existing record. Rarely we do it actually. Store summarized data. Yes, here mostly about summarized data. It is only detailed data. When I say detailed data, as and when however the record comes in, right? See, you made a purchase in the Flipkart, I made a purchase. Like this entire Telangana, some 10,000 people purchased for the sale that has happened. So all the data maintained at a detail level, row by row. But in case of this, mostly we maintain some kind of transactional aggregated data. So that's why we call it as summarized data also can be maintained and detailed data also can be maintained here, right? So these are all the different, it is not much important for you. Just I thought of introducing how ODS look like that, nothing else. You clear, right? So now I go for OLAP, online analytical, processing systems. As I told you, OLAP is nothing but the analytical systems, which means data warehousing tools, whatever the tools we use, why we use those tools, and what is the purpose behind using those tools. So what is the data conversion we are going to do. So all these things we can do with the help of OLAP tools. So OLAP is nothing but two types of operations, ETL tools and reporting tools. Both together we can call it. So these points also represents with respect to ETL as well as reporting. So converting OLTP data into information. So whatever the data we see in database, right? So this OLTP data will be converted into meaningful insights with the help of some reporting tools and ETL tools. That's what it says. So it is for maintaining the competitive edge. Say just when when you're having history in your system, you'll be able to navigate your data, understand how the trend, and so all those things. All these points are mostly we discussed already. So I'm skipping this tool. It is not much important. So this is some one of the main important slide. So I would say like so drill down and drill up. So from our team itself, one person is working in Power BI. If I make you understand what is drill down and drill up. So the data, whatever you have in data warehouse, right? Sometimes people will create in terms of dimensional modeling. What do you mean by dimensional modeling is it is quite opposite to relational modeling. Relational modeling in one hand, dimensional modeling in other hand. Relational modeling is nothing but where data is stored in the help of rows and columns. Simple. Relational modeling is rows and columns. So under dimensional modeling is what it says is, so data is stored in terms of hierarchical modeling to make the data to be consumable with the help of hierarchical structure of creation also. So such kind of tables also we create. So I will tell you see how we do is, suppose data is there. Let's take a Flipkart that has data, customer data, time data, products data, locations data. You understand, right? Product, customer, time, location. Why products? Flipkart is selling products. Why customer? Customers are logging into portal. Why time? It is about login time or purchase time or products brought in time into the market. The portal, Flipkart portal. So all those times will be maintained, right? So like this location. So it is about where it has delivered and who is the vendor selling from which location. So all these things will be stored under location table. Just imagine. So that kind of data we are maintaining different data is there. Four types of tables. Just assume. So when I take time data, what I do is I will create that data in terms of hierarchical way under all the year. It should show all the months. When I click on year, it should expand like a tree. Some websites you would have seen in the latest markets, right? How they wanted to see, they want to drill down. So to see the months. So when I click on a particular drill down month, right? When I click on the month, it should show the dates underneath, and then it shows the extra information also. If it so such kind of look and feel you can be able to create with the help of data warehouse. That's what they mean to say. So slice and dice is nothing but it's about filtering the data at what level. So and multi-dimensional analysis, multiple dimensions will be creating. And I don't know this actually. What if is nothing but I'm not pretty much sure. So we can so that type of operations we can be able to perform OLAP. And the last one, data warehouse architecture, as we were discussing in this notepad, right? OLTP source will be integrated, and we load this data into a staging layer. Sometimes we store this data in terms of ODS. Why ODS? See, the data what being generated in the operational systems, right, on daily basis, which is current valued, temporarily we tend to store in ODS, which is having the capability of data OLTP and OLAP, both features it is having. It will maintain 30 days of data, history of data, not too much of history. Maybe we maintain here on temporary basis, which is we call it as staging layer. So then we do the transformations and then consolidation. We load this data into data warehouse first or data marts first, and then that will be given to some reporting tools. So end of the day, all these tables, what we loaded here, what we brought in from the source systems, we maintain proper metadata management. What I mean by metadata management, right? Metadata. So it is about data only. So the data what we are bringing in, the sources of data what we are bringing into our system. So the columns, the data types, the tables, so who has generated all those stuff will be maintained in a common store called as metadata management. So in my system, what we are doing is real time. I do get files on different frequency, as I told you. So all the files are getting created. So first I'll maintain metadata. So as and when source system is ready, as a data warehouse developer, I talk to the source people. Okay, what are all the tables? What are all the files you are going to give me? Okay, give me a list. I'll maintain the table. So out of the source data, I'll not bring up all the data. I will pick up only data what is required for my data warehouse. I will talk to my customers. I will maintain different tables, some SQL Server or Oracle or something, wherever you comfortable. So we maintain one table. So that table is nothing but metadata table. So in that table, before the source files arrives, source data arrives, I'll maintain one metadata table which contains the tables and columns inside it and the structure of the columns, right? All those things I properly maintain. Frequency of the table, from what business area it is coming from, subject area it is coming from, right? And what is the frequency, how many columns are there, what is the primary key, what is the foreign key, is there any null columns, is there a non-null columns, right? All these data I properly maintain. Why, you tell me? Why? Because see, these source files are coming on regular basis. I'm going to create my data warehouse once, but I'm going to schedule my data warehouse to pick up the daily regular files from the source system. Every time you cannot expect correct data will be populated by source. That is your responsibility as a data warehouse developer. You should be able to validate whether you got the latest data or correct data or not. For that reason, I'll maintain metadata management. That is a separate table. You cannot call it as audit table. That is a operational table. So what I do is, inside my data warehouse tools, right? Let's say Databricks. I'm going to write a programming. So first what I do is, as per the latest data stored in SQL Server or Oracle, I'll pull up the metadata information, just like I'll do once select star from inside my Databricks, right? I'll do one select star from metadata. So it will fetch me all the tables of data. I mean, I'm going to mention my table name. So table name is employee. Table name is employee. So if I do like this, inside my notebook, first I get my metadata. So what are all the columns it has and data types it has? It is, I mean, my system is going to recognize. My Databricks notebook is going to recognize. Once I get this, then what I'll do is I will read my source file, select star from something I do, not only select star from, I'm just selling an example. So source file. So when I read this and I compare the columns available here, structure available here, order available here with the metadata. So when I compare these two, which is nothing but data quality will be verified. If there are any false information has been received, I will try to handle down the same code itself. So I will reject the file, I will stop the loading, maybe I will report to the concern team, or else I will load this data into some part of data is correct, some part of data is unexpected. I will load this data into some fault tolerance databases. I will push there. Later on, I'll pick up the data. I will go and talk to customer who is sending my source files. You got it right. So what I'm trying to say is metadata management is always very clear, important role in the data warehouse environment. So any system which is data factory also, the purpose will be, the way will be different. How they read the metadata and then they compare against a system, source system. So, but validation will be happening on daily basis. Different aspects, they will do. So, one of the interview question, as we are all, I think so, we are all from professional background, some experience we possess. So, I'm telling you, one of the interview questions, I'm going to give separate interview questions, but I'm telling you, they will how your data warehouse is built up. Explain how it has been built up in your ecosystem. If they ask you, first thing is you need to mention about metadata, the way how I'm doing it actually. So I'm going to show you live. So how I validate it and all. So don't worry. So that's a thing. The end of the day, I load this data into first data warehouse or data marts. It's vice versa. Depends on the feasibility of agreement from the customer. They create data marts first or data warehouse first, and then they will be given it to reporting tools. So this layer I'm trying, separately I'm showing. It is already discussed. It is about the sources. What type of sources we are going to get? I told you, right? Sources can be anything. Database data or some files, some flat files, or some server-based files, or some on-premise files. It can be anything. Databricks and Data Factory has a provision to access any kind of file. It matter of creating the credentials with the help of platform team. Okay. And then data staging layer, as I told, right? Olden days ETL and modern days Azure data engineering. Everywhere it is common only. We maintain staging, right? So we in this my premise, I'm calling it as raw layer. What I do is any kind of file I'll pick up, just copy paste into my area. On top of it only, I'm going to process because OLTP systems they are. OLTP system, anytime they're going to delete the source side file. As and when it arrive, you have to go and pick it up. Unless until they are maintaining for at least one day. They don't maintain. If they maintain means okay, well and good. If they are not maintaining, we do have alert mechanisms in terms of event hub, right? Logic app, something we do have multiple purposes are there, multiple tools are there within Azure. In a data factory also, the system will be able to recognize the latest file and arrival. As and when file receives, right, through event grids within ADF, it will be able to read the latest file in the storage location. It will give an alert to you, and then the pipeline will automatically kickstarts to read the data, read the file, fetch the file into our ecosystem. So there are alert mechanisms also. So that's why I'm saying you consolidate all the files, put it into a common staging layer. Then you process it within data warehouse. You clear, right? So that's what I mean to say staging layer. So in case of data engineering, you call it as raw layer, and again it's same. So data warehouse layer, as we discussed, it is maintained in terms of data warehouse in my ecosystem where I am storing my data warehouse data, right? I am storing in Azure storage location in one place. Some of the data, another subject area, I am maintaining in Azure Synapse itself. Synapse has the feasibility to store the data, which is called as data warehouse, Azure data warehouse. There also I am maintaining. You clear, right? So the choosing of the tool varies from client to client. They store in SQL Server. Some people store in uh, Azure storage account if they are strictly about files. If some people will store in, there are new options also arrived in terms of data warehouse. They are called Delta. What is Delta? Maintaining history, versioning, and then logs. It is very comfortable in data engineering side with the help of Delta. Delta is possible through Fabrics and then Synapse, and also with Databricks. Delta is a different file format like Excel file, right? Dot EXL, XLS, what we do have like PDF format, right? It's one of the format is Delta. If you store the format in that format, right, it is very easy for you. But you need to set up something for in terms of Delta. So we'll discuss in detail about that in Databricks class. So enterprise data warehouse, I mean to say same only. Data warehouse is nothing but enterprise data warehouse we call it as. So it is maintained for subject oriented purpose and short term and long term purpose, but mostly for long term purpose only. So I mean to say here, top down approach and bottom up approach. There are two approaches. So I told you, right, let's see bottom up approach first. See, we do have sources. We create data marts first, and then on top of it, we create the enterprise data warehouse. So this is one way of doing data warehouse. So do you understand here? Data marts first, data warehouse next. This is called as bottom up, right? So bottom up, data warehouse coming from bottom. I mean, it's coming from the name only says actually. In case of,
Venkat, one doubt.
yeah, please.
Staging is one of the environment name or it is one of the layer before going to the data marts?
Um, Good question. It is staging is raw layer. I told right, a raw layer. Suppose
Mm.
I take my example, one of my example. My client is pushing the files, source client. Okay, source files over sending it. I'm calling it as like client. So I'm getting the client's information in terms of Parquet. Just imagine in a storage account. So my job is they are going to keep their Parquet files in their system. It is my responsibility by using data factory or data bricks. I'm going to read those files, Parquet files, copy it into my storage location. I'm calling it as raw layer, raw storage account. Raw is nothing but landing layer. We call it as bronze layer also. So once I copied it, it's a storage location. Completely in the Azure portal, it's one storage location. Storage account I created that I showed you, right? So in I create one storage account.
Yeah.
I will create another storage account where I do my transformations. On top of it, I load the data into same account or some other account, which is called as final data warehouse layer. So bronze layer, silver layer, gold layer. So bronze layer is nothing but just copy. I'm maintaining one environment. You can think like it is in one environment, but it is not pure environment. There is no concept called environment. I'm maintaining separate place altogether. Some people depends on their convenience. Within a single storage account, they'll create raw layer, business layer, and then final gold layer or target layer. They maintain single layer itself. So it is a best practice to maintain one storage account for raw layer and the transformations whatever you do, right? We keep it in enrich layer or silver layer. Load this data into data warehouse, which is target layer or gold layer, whatever the namings. So tool to tool it will vary. Why I'm saying bronze, silver, gold, it is purely for data bricks. We follow medallion architecture. In that case, we follow different storage accounts. We load the data into different layers. In case of SQL server also same. Maybe 3 different data warehouse I maintain. So far I'm talking about storage accounts. Let's say I'm getting a table from SQL server as a source. That is my OLTP source. So I will create 3 databases. One is branch, where I get only copy of the source. Second one is processing. Third one is gold layer. Finally, it is the target layer, or you can call it as data warehouse table. So we don't call it as environment. I would call it as layer. Here, all about layers only. Okay. Medallion architecture is one principle. Data warehouse who has invented something like Kimball, we call it as. Kimball is the founder of data warehouse. So there are proposals came from different, data engineers. One of the person who proposed Databricks, best architecture is Medallion architecture. His name is Medallion. So that using that we maintain best practice as what we get source we store in bronze layer, what we get what we polish or transform, we call it like a silver layer, load into the gold layer. Just your convenience how you maintain. So it's a practice we follow. That is what the staging is nothing but in case of ETL tools. How ETL tools does, in case of ETL tools, suppose let's say SQL itself, just they bring in the raw tables, they put it into staging for temporary purpose before it is processed to data warehouse. So every table, suppose employee table in the target table, I would like to see employee. I will maintain the table as employee underscore staging. All the tables will be maintained with the stage underscore staging, and the database name, schema name will be maintained with staging, just for recognizing purpose. So on top of the staging only, they do the transformations load into the data warehouse. Am I clear? Am I clear?
Got it. Got it.
Okay. So here top-down approach, bottom-up approach. It's very clear. The bottom-up approach, the top-down approach you see, right? It is coming from data marts next, data warehouse first. So bottom-up approach first, data marts first, and then data warehouse next. So just if you ask me what is the best practice, bottom-up approach is the best practice. This is what I'm also following in my system. Okay. So I will move on to next set of data version concepts. They will not be repetitive like so far whatever we repeated, but here it will be more no, informative. Let's see what I'm going to discuss today. So I will take an Excel just to showcase. So let's take Flipkart. So Flipkart is my client. Suppose you are working, we are all working for Flipkart. So what type of data will be get generated? Products. This is one table or one file. It can be a file, it can be a table in data warehouse. Anything it can be. So under time, ID, product name, right? Description of the product, um, product type, what type of product it is, and vendor vendor is separate table, maybe we can maintain. So like this, I'm taking minimal columns, I'm not going in depth. So I will take ID column, the time column here, maybe we will see some time keys, and then we'll be having some year, month, something like this, day, month. So any kind of information, quarter, whatever it is. So and then I do have one location table. Here I'll be having a location table. So location ID, country, region, state, anything, whatever you know, district, something as per your convenience. You can fill this data. So what I'm saying is, these tables, apart from this, maybe one sales table. Here I'm maintaining few sales columns. I'll have like all the keys, the location ID, right? Location ID and product ID and time key. I mean, not it will not be like this. Probably it will be like this actually in real time. I just mentioned for my convenience. Okay. So product ID, location ID. So the same applies to here also. It should be location ID. Okay, and then I'll be having price, MRP price, discount, any other columns will be maintained here. So now you see here data will be 20,000, and then discount what has been given is some 2000 has been given as discount for this product. So product what I have sold is ID is 1, and location is 101, right? So this is how sales table is maintained. So here it is location ID 1, location is 101, yeah, 101, country is India, and state is Telangana, and district is something okay, Hyderabad itself. So something like this if I have, uh, I have, and the time also I'll be maintaining the same way. Now what I'm trying to say is, the data what you see here, like here, whatever the columns are there, they are called as identifiers. Whatever the fact columns are there, measures are called as facts. These are measures, right? These are identifiers. The joining columns, location columns, and this is also, this column also should present in fact table. So this column will be present in fact. These are, so these should be in a different coloring. So this is a attribute column. Sorry, I supposed to put in with this coloring. Yeah. So with this coloring, so all the fact columns and ID columns, I put it in yellow color. They are called as identifiers. But whereas this month and the name, all these columns, right? I'll call it as attributes. This is the terminology. So I do have totally three types of columns: facts, are, measures, okay, keys. Actually, for identifiers should be, it should be identifiers, also called as keys actually. Identifier is the best term, and then attributes. So any column other than identifier, other than fact, all the columns are called as attributes also. So in a fact table, they maintain all the sales information, numbers. In case of time, they maintain it will be constant across multiple data warehouses. It can be extended to many data warehouses also. And products will be, you will be having identifier and attributes. Here you will be having one identifier and all other attributes also. Not only one identifier, it can be anything also, many identifiers also. Just for the namesake I told. Oh, I think I should put it in different coloring. Like this. You clear, right? So the data is differentiated into three types: identifiers, attributes, facts or measures. Okay, so that's what we're going to see in this session. So irrespective of any column, identifier, attribute, anything, right? We call it as like entity. Every column is called as entity. You can call it as entity. And next thing is attribute. So attribute in the sense, in a table, actually here I supposed to put identifier screenshot. Haven't put. So sorry, my mistake. Identifier should be ID columns. Here it is attribute. Other than fact columns, right? Any column can be called as attribute. That when the matter it comes, ID column also can be treated as attribute. General terminology is attribute. When you want to specifically divide a column, whether it is identifier, attribute, yeah, it is identifier. So in a table, all the columns are attributes only. Clear, right? So and then specifically, if you talk about the same column than previous slide, I'm calling this as identifier. When I'm joining this column, I'm using this column for some joining purpose or uniquely identifying purpose. Uniquely identifying purpose. I call it like identifier. Sometimes you will not have ID columns also in data warehouse. So some name columns also, I call it like identifier. I'll tell you one example. So identifier is nothing but uniquely identifying pattern. So I will say in a day, a company has a policy. In a day, it will recruit the employees with one name, and in a particular day, only one person will be same name. They will not allow duplicates. Just imagine, in a company, date of joining is there and name is there. So with these two columns, both are attributes only. With these two columns, joining date and the name of the person, it is uniquely identified. So no person will be joined with the same name on the single day. That is a class a company has. Just imagine. Combination of joining date and employee name. If I say unique, it is not duplicate. You can use attribute column also as an identifier for joining purpose. Joining is not only about identifiers, it is about attribute columns also. Only what it matters is whether you are able to make it uniquely identifiable or not. Okay, so that's what I mean to say. Any column which is used for join, I call it like identifiers. With the help of identifiers, people will join all these my tables. Here I clearly mentioned, right, all these columns, how I wanted to make my join. Here I should put key as well, location key as well. I haven't put maybe this key is how I design, 2024 year, combination of year and month is 11, sorry, 12, right? Yeah, 12 and 3. You got it, right? For the day of transaction, what is happened? Just here I'll having I'll be having 2024 and month as 12 and the date as 3. Clear, right? So this is the key actually. We generate or by themselves from source system itself, we get it sometimes. So this key will be there here also. So we gonna join all these dimension tables with the fact table. What is dimension table? All these are dimension columns. In a table, when you have identifiers and attributes, we call it as dimension tables. Dimension tables equal to identifiers plus uh, attributes. Fact tables equal to identifiers plus facts or measures. So these are the two types of tables we used to refer. I mean, there are many other tables also. Factless fact tables, surrogate keys. There are other concepts as well. We will see down the line. So this is how real time how the tables will be joined. I took one example with a limited 4 tables I have shown you, right? In case of this, you see supplier table, customer table, retail, wholesale, separate definite. I mean dimensions and tables are there. So that will be joined with one sales table, which is a product table. Mostly you will be having all the information will be maintained one fact table, and many other fact tables, many fact tables also, but all are created for different purpose. In my case, in my project, right, what I'm doing is I work for retail customer itself, but not Indian retail companies. So UK retail companies. So the UK retail company, I'm maintaining customer as one dimension. Sorry, fact table. I supposed to tell you fact table, sales details in one table, and then discount table in one table, one fact table, discount table. So there are situations, some reporting people are connecting to two fact tables at a time in their project. That's happening. All the tables we are only loading. So it depends actually. Mostly one fact table will be there. It's not one single subject area I'm talking about. Maybe for if you're working for multiple subject areas, like my case, I'll be having multiple fact tables also. So two fact tables also can be connected with the help of one dimension table in between. That is different concept actually. So I am trying to show here what is a fact, right? It is a fact what can be used for calculating some other columns, which allows summary on top of them. Not all the columns allow summary. I mean, to aggregations. A name column cannot allow, some count or total, right? It's senseless. So that's what facts allows us to create some KPIs, key performance indicators. So Power BI developer in our team, right? He knows it actually. So how it can be used. Those dimension columns, like what it sold, that means product, whom it sold, customer, when it sold, time, where it sold, location, right? These dimension tables will put facts into a meaningful, information. If simply I say revenue 20,000, it doesn't make sense. So revenue for Hyderabad location is 20,000. It makes more sense. So that's what dimensions puts facts into a meaningful information. Clear, right? So that's what the next slide it shows: product information, service information, geographic information, nothing but location, time dimension. Different type of dimensions are there in data warehouse. So I was telling you, right, hierarchy. What is drill up and drill down? You see, uh, from bottom top, you do the uh, these tables in real time will be joined when you are aggregating top to bottom or bottom to see, data is given at detail level. Sometime you wanted to aggregate it. That means drilling down, drilling actually drilling up, drill up. Data is given at day level. Daily transaction what you made in the Flipkart is given in a row wise. So now we are going to do consolidate and take a total of weekly wise. What it does means, it means you are drilling up to the higher level, which is the week level. So if your aggregations are happening at it's not exactly we can do when source itself is given a month level, I mean to say, data will be given from the source system as detail level only. But the way we create hierarchies, right, inside reporting tools will make sense. We can make till drill down and drill up. Some hierarchies can be created. We all keep all the months, all the dates in one time. So for the time being, we keep a calculated column. Total of sales we put. So when you keep two columns together, it will do the drill up, drill down. So it's a different concept. We can try it in SQL Server when this actually real time data is available. Yeah. So these are all the different dimensions, and multi-dimensional analysis. It will allow data warehouse allows. That's why we call it as like OLAP. Drill up or drill down. It is clearly shown here. You see here, right? First quarter, which is about 20.4. The first quarter is nothing but for Easter. So January, February, March. If you additive all these things, it will sum up like 20.4. So I thought of telling one point actually here. One important data warehousing question people ask is how many types of facts are there? Additive, semi-additive. It's like a very good concept. When some columns cannot be sum up, you cannot do aggregation on top of them. So there are three types of columns. I will show you with data tomorrow. So three types of facts. Just you can also explore it. How many types of facts are there? Semi-additive, additive, and one more is non-additive. You can never add the. I mean, it's a measure, but you cannot perform aggregate on top of them. Let me give an example. Percentages. Percentage is one column. You will keep in Excel. See here itself, you will be having discount percentage. Are you going to do addition of that? It doesn't make sense actually. Percentage of discount you are giving. So that is non-additive. Something like this. Facts are three types: additive, which can be added and subtracted, something multiplied, something like that. Non-additive, you can never add it. So some columns can be additive, some cases they cannot be. I'll give you if you want more details about them with some data examples. So I will move on to this area, dimensional modeling. It is very important. Why I kept this slide is dimensional modeling is nothing but, see, I'm creating a data warehouse out of my source data like this, but how this can be properly utilized by my customer. My customers not only reporting people. Nowadays, era has changed. People from machine learning also trying to access my data. I don't know how they are consuming. I don't know. Machine learning, AI people also consuming with the help of Databricks. So they create their models on top of my data warehouse data. It depends. So what I'm trying to say is, I should have to keep my data in terms of dimensional modeling. What do I mean by dimensional modeling is, you just see here, there are four types of modelings. I never worked on this, at least just whatever was there, I have kept here. Although I know I never explored because people, 100% people won't use this. So star schema, snowflake schema, mostly used in my project. People are using snowflake. We are building snowflake models, not star schema models. But mostly how the people build data warehouses in this model only. What do I mean? Dimensional modeling of star schema pattern of dimensional modeling. What is that? It is simple that I create a fact table. All the dimension tables will be surrounded. You see here, what I do is, this is my fact table. I keep it in the center. I'll have my, you know, tables like this. Sorry, I just properly not cut down that. So sorry for me, so I wanted to connect all these tables. Every column from this, customer location dimension, product dimension, time dimension, all are having one column here to join. So I'm able to join with the fact table. All these dimension tables are surrounded. So I call it like star schema. So mostly people will follow this. Any dimension table introduced here, right? We will make a join to fact table here. So Snowflake schema is not like that. So any doubts? Vishal, any doubts? I take it as no. Okay, so that's what is mentioned here. Fact table will be in the central, in the center. All the product table, customer table, one common key will be there, right? Unique column. That common unique column will be there in employee table also. So customer will be able to join with fact table. Product will be able to join with employee table, and the same with employee dimension table, time dimension table also. So all the dimension table will be having a foreign key here and primary key here. What is one way foreign key? What is one way primary key? All these are FKs, which means foreign keys, referential keys. These are the main keys from the dimension tables. So this key will be there here also. This key is called as FK, foreign key. So primary key, it will be there here. Primary key will be there here. This is my primary key. You got it right? You got it right? So all the primary keys will be there in the dimension tables. Same kind of keys will be maintained in the fact table also. I call it foreign keys. So that is what is mentioned here. So if I go in detail, this will show you very clearly. See here, fact table I do have employee code. This employee code, a column in the foreign key. This employee code is acting as a foreign key. The same employee code is maintained in employee dimension. Where is employee dimension here? Yeah, here. Employee code. So actually it is not properly maintained while cutting down. I just took some screenshots while pasting it. It had some mistake. So this is the employee table where I'll be having joining actually. So joining, employee dimension table. See here employee table as well as location information both are covered here in a single table itself. Employee code, employee name, and location. So the same product code here it is working as a foreign key. This product code is there in product table also. Now the fact table will be able to join with product dimension table. So this product code is nothing but primary key. This is a foreign key. So all the columns which are there for joining purpose in fact table, they are called as foreign keys. All the columns which are enabled here for joining purpose, they are called as primary keys. So this is how data warehouse will be built on. My case, it is not the case because I do have multiple dimensions. I work for a retail company. I am not choosing the star schema. Instead, slide change will be there. Let me show you that. This is how my snowflake schema. My project is running like this. So I do have fact here in the center. Some dimension tables will be directly joined with the fact table, and some dimension tables will be indirectly joined with the fact table. See, region is joined with city. City is joined with fact table. Let me show you how it looks like. Now what I do is location dimension. Where is it? I'm going to have, this is location. I do have low level, let's say another location dimension. Here I'll be having address kind of table. So my village, my street, right, and my mandal. And I'll be having one location ID. Sorry, it should be supposed to kept in the starting itself. It should not be kept here. I'll cut this, paste it here. So now this I'm going to use as a, now I'm going to use this as a identifier to join with this column. So this and this will be joined, and again this will be joined with this location table will be joined with fact table. You clear, right? This is a primary key. This is a primary key. Again, when I'm joining these two tables, this is my primary key and this is my foreign key. You clear, right? So I'm going to join this way. So end of the day in snowflake schema, dimension tables are, few dimension tables are straightly joined. Few dimension tables are indirectly joined to the fact table. So my system is running based on this. I mean, mostly people will use star schema only because of the advantages. Because of the advantages. What is the advantage you have? Performance will be faster. when you want to get see, this is my data warehouse. I have the flexibility. I'm able to join all these 4 tables or 5 tables in a single query in Power BI or any other system. I'm able to do joining. The provision is there, the columns are available, readily available, I can be able to join. So but the point is that if I wanted to join only location table, sorry, low level location dimension with fact table, that is my requirement. Village level sales I wanted to see, my customer wanted to see. So in case of snowflake schema, 3 tables I need to use. One is this, second is this, and third one is this. Snowflake schema case, because I cannot directly access this data. I don't have provision to access my village table from the fact table. So star schema means if it is star schema, this will be maintained here. Directly I will be able to join this village table with fact table. But why people will go for that type of dimension when you wanted to maintain fact table huge data with a huge dimension tables when you have in place, right? It is not so easy. How we discuss all the fact tables cannot be enabled on top of the fact table. So as much as uh, aggregation you need to keep in the fact table. So if you keep village level data, I cannot make my summary data more clear. So it is very problematic, and making columns data maintenance is very clumsy in terms of snowflake schema. But my project will be based out of huge number of dimension tables. That's why we chosen over star schema, right? So performance will be slower in terms of fact tables. Since I'm using cloud tools, yes, I'm using Apache Spark kind of coding, I'm doing it very faster than any other thing actually. Otherwise, if it is SQL server general ETL tools, I would have chosen star schema. I got the provision actually. Hybrid schema, nothing actually, it is like a combination of both star schema, snowflake schema. This also no people will have used. At least in my experience, I never come across this hybrid schema. People always go for either star schema. Very rarely we go for snowflake schema. So next important concept is slowly changing dimensions. Very, very important concept. If you go for interview also, it will be a damn sure question for you. So slowly changing dimensions. So far, any doubts?